Factorizing of two squares. Learning intention. To learn how to factorize expressions that are the difference of two squares. Success criteria. I can recognize when an expression is a difference of two squares. I can write a difference of two squares as a product of two brackets. I can apply the pattern a squared minus b squared equals a plus b times a minus b to simplify expressions. Difference of two squares. Numbers such as 1, 4, 9, 16, 25, ... are called perfect squares, as they are obtained by multiplying some whole number by itself. For example, 4 is equal to 2 squared, so 4 is known as a perfect square. 9 is equal to 3 squared, so 9 is known as a perfect square. So these are the first few numbers of the square number sequence. So 1 is the first number because 1 squared is 1. Then we have 4 because 2 squared is 4. Then 9 because 3 squared is 9. Then 16 because 4 squared is 16. Then 25 because 5 squared is 25. So the next square number would be 36 because 6 squared is 36. And the next one after that will be 49 because 7 squared is 49, and so on. Similarly, in algebra, 4x squared is equal to 2x to be squared. And 9y squared is equal to 3y to be squared. Expressions such as 10 squared minus 4 squared, x squared minus y squared, and 4x squared minus 9 are known as the difference of two squares. When you multiply x plus y times x minus y, you get x squared minus y squared. Thus, the factors of x squared minus y squared are x plus y times x minus y. So in words, the first squared minus the second squared is equal to the first plus the second multiplied by the first minus the second. Example 1, factorize, part 1, x squared minus 9. So when we're factorizing, we first have to recognize the difference of two squares. So if we were to try the highest common factor method, it would not work here because there's no number that will divide into both terms, and there's no letter common to both terms either. We can't use grouping because grouping is when you've got 4 terms, and we can't use the quadratic trinomial method because that's when you've got 3 terms. So the only other type of factorizing left at ordinary level is the difference of two squares. So let's have a look and see if we can use the difference of two squares here. So that's a minus, so it's a difference. X squared is a square number. And 9 is a square number. So we have the difference of two squares. So we're going to have two sets of brackets. One's going to have a plus in the middle and one will have a minus in the middle. We're going to square root the first term. The first term is x squared, and the square root of x squared is x because the root and the squared cancel. So x is going to go in the front of both brackets. It's very important that it goes in the front and not the back. The square root of the first term must go in the front of both brackets. Then we're going to square root the second term. So the square root of 9 is 3. So 3 is going to go in the back of both brackets. And there's our answer. So if we're asked to factorize, we must have brackets in our answer. And if we factorize x squared minus 9, we get x plus 3 multiplied by x minus 3. So this is our answer, but we're going to check by multiplying out the brackets. And we end up with x squared minus 9, because the minus 3x and the plus 3x will cancel. And that's what we started with, so we know we're right. Part 2, a squared minus 25. So again, you want to investigate and see what type of factorizing you're going to do. We have a minus in the middle, so that's the difference. A squared is a square number. And 25 is a square number because 5 squared is 25. So we have the difference of two squares. So we have two sets of brackets. One has a plus in the middle, one has a minus in the middle. So then in our rough work, we're going to get the square root of the first term. So the square root of a squared is going to be a, because the root and the squared will cancel. So the a is going to go in the front of both brackets. Now it has to go in the front, not the back, because it's the first term. So the square root of the first term will go in the front of both brackets. And then we'll square root the 25, and we get 5. So 5 is going to go in the back of both brackets. So here's our answer. We are asked to factorize a squared minus 25, and our answer is a plus 5 times a minus 5. So this is our answer, but we're going to multiply out the brackets to check if we're right. And we are. A squared minus 25. We're back to what we started with. Factorize each of the following. So we have x squared minus 4, x squared minus 16, y squared minus 36, y squared minus 100, and a squared minus 9. So these are all the difference of two squares. So we're going to have two sets of brackets, and one will be a plus and one will be a minus. So the first one, the square root of x squared is x, so x goes in the front of both brackets, and the square root of 4 is 2, so 2 goes in the back of both brackets. The next one, the square root of x squared is x, so x goes in the front of both brackets, and the square root of 16 is 4, so 4 goes in the back of both brackets. Then the next one, the square root of y squared is y, so y goes in the front of both brackets, and the square root of 36 is 6, so 6 goes in the back of both brackets. The next one, the square root of y squared is y, so y goes in the front of both brackets, and the square root of 100 is 10, so 10 goes in the back of both brackets. And then the last one, the square root of a squared is a, so a goes in the front of both brackets, and the square root of 9 is 3, so 3 goes in the back of both brackets. Example 1. Factorize. So hopefully you notice that each of these are in the format of the difference of two squares. So we have a minus in the middle of each two terms. 9 is a square number, x squared is a square number, 4 is a square number, 25 is a square number, a squared is a square number, 81 is a square number, b squared is a square number, x squared is a square number, y squared is a square number, 4 is a square number, a squared is a square number, and b squared is a square number. So we have 3 examples, and all of them are the difference of two squares. So part 1, 9x squared minus 4. So we have two sets of brackets, one's a plus and one's a minus. So we're going to get the square root of 9x squared, and that gives us 3x, so that goes in the front of both brackets, and the square root of 4 is 2, so that goes in the back of both brackets. So then we check by multiplying out our brackets, and we get back to the start, so we know we're right. Part 2, 25a squared minus 81b squared. So we're going to have two sets of brackets, one's a plus, one's a minus. Then the square root of 25a squared is going to be 5a, so that goes in the front of both brackets. And the square root of 81b squared will be 9b, so that goes in the back of both brackets. And then we check by multiplying out our brackets, and we get back to the start, so we know we're right. Part 3, x squared y squared minus 4a squared b squared. So we have two sets of brackets, one's a plus and one's a minus. We get the square root of x squared y squared, and that's xy, so xy goes in the front of both brackets. And then we get the square root of 4a squared b squared, so that's going to be 2ab, so 2ab goes in the back of both brackets. We then check by multiplying out our brackets, and we get back to the start, so we know we're right. Factorize 12x squared minus 75y squared. So again, we have what looks to be the difference of two squares, but we actually have to be very, very careful. So we have a minus, so that's a difference. X squared is a square number, and y squared is a square number. But 12 is not a square number, and 75 is not a square number. So what we actually have to do first, and what we should always try first, is the highest common factor method. So this is the difference of two squares, but it's in disguise. So before we can do the difference of two squares, we have to first do the highest common factor. So first, take out a common factor. So 3 is going to be the highest common factor. So 3 divides into 12, and it also divides into minus 75. So 12x squared divided by 3 is 4x squared. And minus 75y squared divided by 3 is minus 25y squared. Now what's left inside the brackets is the difference of two squares. So we have a minus for difference. 4 is a square number, x squared is a square number, 25 is a square number, and y squared is a square number. So we have the difference of two squares inside of the brackets. So this is why I said the difference of two squares is in disguise, because it's hidden inside of a different question. So we're going to have two sets of brackets, one's a plus and one's a minus. We get the square root of 4x squared, which will be 2x, and that goes in the front of both brackets. And the square root of 25y squared is 5y, so that goes in the back of both brackets. We can't forget about the 3 that we had up here. Don't forget to stick on the highest common factor. So we stick on the 3. We can't forget about the 3. So we check by multiplying out the brackets. And we get back to the start, so we know we're right.